Okay, hello everyone, welcome to our fourth video. So in this one, we're gonna make a quick introduction to Hadoop. So Hadoop was released in 2006, almost 18 years. So it's a framework to handle big data. So the whole purpose of Hadoop is to store and process big data when we have a cluster with multiple nodes. So our data and the processing both are distributed in our network. There are like three key components, but they're not the only ones. The components are the HDFS, which is the Hadoop Distributed File System. So the purpose of the HDFS is to handle the storage of the data. So it takes the data, it splits the data, and it moves data, like in the whole cluster. It creates even some replicas of the data, so it gives like reliability to the system. Yarn is yet another resource negotiator. Since we have a network here with multiple nodes, so it is important to manage the resources of the network. So Yarn takes care of the jobs that are scheduled inside that network. So that means that the storage, the processing, all the hardware and the resources in general are handled by Yarn. MapReduce, we already discussed MapReduce last week. So it's a programming model to perform the parallel processing. So it assigns the task to the different nodes of in our network. So Hadoop is usually used like largely in different organizations. Even though it has been 18 years in the market, it still is a good alternative when we're handling big data. So as I told you before, Hadoop is not just HDFS and Yarn and MapReduce. There are like different packages that kind of like work together in the Hadoop ecosystem. So in this course, we will go over Hive, Pig, and HBase. So in the case of Hive, it's to like explore our data using SQLite syntax. You can access the data. So it's very useful for analytics. Pig is for scripting. HBase is not SQL. So these three tools are really important when you wanna analyze your data, do like some exploratory data analysis, even when you want to create some models, do some analytics. So it is possible with these alternatives. Okay, so as I told you before, Yarn it's important because in the environment of big data, the resources you have to use them in a smart way, because there are some challenges in big data. We have scalability, so data is going to be growing. Then we need to allocate resources dynamically. We have fault tolerance here. The system in Hadoop, it's one of the main claims is that fault tolerant. That means that it distributes the data in different nodes of the network to be redundant, right? To provide more reliability in the system. So managing distributed resources means handling those failures efficiently. This part is also really important, the multi-tenancy. So Yarn supports multiple users and even multiple applications running jobs in the same cluster. Okay, so the key responsibilities of Yarn is to manage the resources. So that means CPU, memory, across the applications. The job scheduling decides when and where applications, in which part of the cluster they are going to run. And the multi-tenancy refers to running multiple frameworks. So it is possible to manage MapReduce, Spark simultaneously on the same cluster. Okay, now let's talk about the HDFS, the distributed file system. So one of the big claims here is that we can scale our data, like we can increase the amount of data, so we can store petabytes in thousands of nodes inside the cluster. So one of the main claims of this system, the fault tolerance, that means that we can replicate data across multiple machines. So for example, here in this figure, if you notice, we have this piece of information here, this data, and we have it here in a different node. So they are replicas. They are the same, but for reliability purposes and for redundancy, they are stored in different machines or different nodes. Okay, so in the architecture of the HDFS, there is a name node, which is like the master. So the name node, it's like regulates all the access to the files, and it knows like where the data blocks are stored in the whole network. And then we have the data nodes. They are like the slaves in the system, and it's where actually we are gonna store the data blocks. So let me show you how it looks. So we have the name node here, the master, and then we have the multiple data nodes where we store our data blocks. And as I told you before, there will be like replicas of these boxes. For example, if you have like package number 1, it may be distributed here and even here. Okay, so how data is stored using the HDFS system. So files are split into blocks. So typically the size will be like between 128 megabytes and 256 megabytes. So all the blocks are gonna have the same size, but the only one that is gonna be different is the last block of the file. And they are stored across multiple data nodes. So typically, this is the default. You're going to replicate each block like 3 times. There will be in 3 different data nodes. That's the default, but it can be changed. So, and as I told you before, if one of the nodes fails, then the file will be accessed and it will be replicated again in order to keep the same consistency in our data. So fault tolerant via replication is key. And another important feature here is the heartbeat and block reports. So what are those? Data nodes, like all the time, they send regular heartbeats to the name node to indicate that they're still active, that they are like working properly. And block reports help the name node to keep track of data availability. There are alternatives, of course, to HDFS. Now with the cloud services, for example, in Amazon Web Services, you will find the S3 service, which is an alternative to HDFS. Same thing with Google Cloud. Now with these services, there are some benefits. For example, scalability. So you can like keep increasing. That in general is like the amount of storage that they offer. It's unlimited for a company. Durability. So it's gonna like these files are gonna be even in different geographic regions, so that kind of like gives more reliability to the system. All right, so the key conclusions here is that Hadoop it's not just like a piece of software. It's a ecosystem actually, and it has several components. So the key components are the HDFS, the MapReduce, and Yarn, but there are other packages that are really useful when you are like extracting some value from our big data. There are alternatives, that's also important, and I hope that we're going to discuss some of these alternatives in more detail as we progress in this course. So Amazon S3, Google Cloud, they are getting more popular, and they are alternatives to HDFS. So in our next videos, what we will do is that we're going to start using Hadoop, actual coding, so more like hands-on. We will analyze the HDFS components, same thing with Yarn, and also what is Hive, Peak will be covered in the course. And of course, Spark, which is like quite popular nowadays, it's also going to be discussed in our future lessons. So I'm going to stop for today. I'm going to see you in the next video.